Let's take a look at this example. Several clubs want to meet once a week, but some of the officers serve in more than one club. So knowing the context of what we're doing and knowing that there are going to be conflicts, here's the situation. If we read ahead, like Robert is an officer in the math club, pep band, and chess club. So there's going to be a conflict, which means math club, pep band, and chess club can't meet on the same day because Robert can only be in one place at a time. It's a human fallacy, I know. How many different days should the clubs meet? Which clubs meet on the same day? So we really need to, start by creating a vertex edge graph. Now, when I first read this problem, I thought, okay, is our vertex edge graph going to deal with Robert, Cameron, Vivian, Rachel, and Aaron, or is it going to deal with math, pep, chess, fencing, science, German, what is it? And I realized that the conflict wasn't about the people, it was about the clubs. So there is a conflict that math and pep can't be the same day. And that conflict is Robert. Robert's the one causing all the problems, and Cameron and Vivian and Rachel. But the problem is that when I connect things, when I look at this problem and read it in context, the things that can't meet at the same time are the clubs, not the people. And it's actually in the first sentence. Several clubs want to meet once a week, but some of the officers serve in more than one club, so the clubs can't conflict. So long story short, your vertices are the clubs. So we have math, that's the fun club. We have the pep band. We have chess. Pep band would be a fun club too. Chess club, fun club. I'm going to stop giving opinions on all these clubs. Fencing club, that does sound like fun though. Fencing for sure. Science. And the German club. If you're not German, well, you may not be in that club. Oh, it's about the language. Okay, sorry. So Robert is an officer in the math club and the pep band and the chess club. So what it really means is Robert can't be at the math club and the pep band at the same time. And Robert also can't be at the math club and the chess club at the same time. And Robert can't be in pep band and chess club at the same time. So there is a conflict among these three. So these three are all connected to one another because Robert is an officer in all of them. And so therefore, automatically, just glancing at what we have, we know that we're going to have at least 3 different days. It might be exactly 3, it might be more than 3, but it won't be less than 3 because Robert is already involved in 3 of these things. He's an overachiever. All right, Cameron is an officer in the math club, the fencing club, and the science club. So there's a conflict because of Cameron between math and fencing. I think fencing can solve that problem, whatever conflict there is. Touché. So math and fencing, there's a conflict between math and science, and a conflict between fencing and science. All right. Vivian is an officer in pep band and German club, so pep and German have a conflict. We'll swing that one around here just because I didn't want to cut through the middle. I probably will have to eventually, but that's okay. Rachel is math and chess. Oh, we already have a conflict. So Rachel and Robert are kind of in the same situation, at least in terms of math and chess. And Aaron is an officer in math and science. So again, that one's already taken care of. So there's our vertex edge graph. And we are going to make our table. And our table is going to have, math and pep and chess and fencing and science and German and we are going to put our degree right here. This is the easy part. Math has a degree of 4 math degrees. 3 pep, 2 chess, 2 fencing, 2 science, 1 German. And then over here we will put the day of the week. Now you may want to put a day of the week. You may want to put Monday, or you may want to put purple, or you may want to put number 1, number 2. You can do it however you want to. We don't have to assign them to a specific day, but we are grouping them into different groups. Whether you do it by number, by color, by day, by put smiley faces and frowny faces, I really don't care. But we start with the highest. Okay, the highest is math. Actually, as we go from high to low, we're really reading right down the chart. So this is one of those rare exceptions where everything, if we do it in this order, is already in order for us. So we start with math and we say, well, math is going to be day number one. Day number one, and so we're going to call math day number one, Monday, red day, whatever you want to call it. So there's math. And I need to see who else can meet the same day as math. Well, not PEP, not chess, not fencing, not science, but German can. So German will also be day number one. Okay, that's fantastic. Let's switch colors. We've gone from red day. Let's go to green day, which is a band. All right, the next highest degree is PEP, which is 3. So PEP will be on the second day, also known as Tuesday. Yeah, it was lame, I know. But PEP will be on the second day. And we also want to see who can meet on the same day as PEP, which clubs can meet on the same day as PEP, not chess. Fencing can, science can. But again, let's be cautious. Fencing and science can't both meet together. So fencing and PEP, cool. Science and PEP, cool. Fencing, science, and PEP, no. These two can't be on the same day because somebody has a conflict, and I think it's Cameron. Way to go, Cameron. So PEP is number 2, and we pick one, and it doesn't matter which one we pick. Normally we pick the one with the highest degree, actually, but in this case they both have the same degree. So again, said it many times, but there are multiple possible answers for these. So I'm just going to pick science because I feel like it. And that, my friends, is number 2. That is 2 this day. All right, day number 3. Also known as Threes Day. Chess, fencing, actually they can be on the same day. It's totally okay. We can go down our list, and they have the same degree, so we could pick either one, but actually we can pick both. So this is going to be on Threes Day, which is going to be black. So chess, fencing. Great highlighting job with ink there, huh? So the final answer is going to be 3 days. So let's actually answer the question in words. How many different days should the clubs meet? We need, you can word it however you like, but I'm going to start with we need. We need 3 days for the clubs to meet. And then which clubs meet on the same day. And I would love to write all that down, but that information is in the chart. So I'm not going to write all that. But math, German, same day. Science, PEP, same day. Chess, fencing, same day.